Alright, welcome back everyone. This week we are talking about force. So, in science class this week, we recapped that force is a push or pull. Now, when we talk about force, we also like to think about net force, which is the total force acted on an object. So today I'm going to be doing a few problems with you to show you how to calculate a net force. It's pretty simple, but I figured some extra practice wouldn't hurt. So let's start with question number one. So question number one. Before we begin, actually, I'm going to go ahead and show us, let's skip ahead, something that will help us when thinking about net force. So when we have things moving to the left, so that means they're moving to this direction, that is negative. Okay, so think of a negative number, same thing as a number that you subtract. Okay, so if it's going to the left, that's a number we subtract. Numbers that go to the right, or forces that are acted upon to the right, are positive. So think of these numbers that we add. Okay, so just keep that in the back of your mind as we work through these problems. So again, force is a push or pull, net force, total force. So here, first question we have an object here with a force going 4 newtons to this direction, which is the left. Okay, so 4 newtons. Now the N is our units, which stands for newtons. Okay, the reason why is because Newton discovered the 3 laws of motion. Okay, so he named it after himself. Alright, well, again, this object is moving to the left. Now, if you do not know your left from your right, here's a really quick way for you to remember. I want you to hold out your arms right now, and I want you to try to make an L with your hands. Okay, so your left hand will look like this, your right hand will look like this. Okay, this is your thumb right here, this is your thumb right here. So you do that, and the one that is the left will look like an L. The one that is not is going to look like this. Not an L. That is the right side. Alright, so just to recap, some of us don't know left to right, and that's a really good way to remember. Alright, so anyways, 4n to the left. There is only one force here, 4n, so our net force is 4n. Alright, now here we have 2 forces. We have a force going this way and a force going this way. Now, the arrows, you will notice they are different sizes. Different size means they have different amounts of force. The bigger the arrow, the bigger the force. So, what we do here, we are going to do 7n and 2n. Now remember, if it's going to the left, it's negative, so this is actually 7n. Negative 7n. And then we have 2n going to the right, so that's positive. So what we do, negative 7 minus 2, negative 7 plus 2, this would be negative 5. Now, if you don't know how to work with negative numbers, you can just do 2, which is the positive number, minus 7, because that's going to the left, and this will be negative 5. Okay, same thing. So that is actually our answer. Now we can write it like this, 5n, and then you write what direction. So we're going to write to the left. Okay, I actually forgot to do that over here as well. Alright, so Pretty simple. You can add them like this, or you can subtract. Okay, it's two different ways. I know this is a lot. I'm going to do another question. Maybe this will help. So, we have 4n. Alright, 4n, and it's going to the right. We have 4n over here, and it is going to the left. Alright, so 4n going to the right, 4n going to the left. We can do 4 minus 4. That equals 0. Now we need to include our units. 0n. And since it's 0, that means it is not going to be moving in any direction, or it is balanced. If it is moving, like number 1 and number 2, that means it is unbalanced. Alright, we're going to do one last one. So we have here 6n going to the right, 3n going to the right. So they're both going the same direction. If they're going in the same direction, you just add them. So 6n plus 3n, that equals 9n. And it is going to the right. Alright. So here's just a few more examples. You can work on these. I will include this in the Nearpod. The rest of these questions, I want you to answer these. Now, I also want to talk a little bit about what it means to be balanced and unbalanced. So, I want us to focus here with balanced, okay? So, if something is going at a constant speed, okay, so not changing speeds, same speed, not changing direction. So, in other words, it would have the same velocity. That is balanced force, okay? So there's no change in motion. So if it doesn't change in speed, if it's at rest, it stays at rest, that is balanced, okay? So think of it, if it's staying the same, okay? It doesn't matter if it's moving, it doesn't matter if it's not moving. If it's staying the same, it is balanced. All right, now we have speeding up and speeding down. This would be unbalanced, okay? It is changing speed, so that means it's unbalanced. If it changes direction as well, that's unbalanced. Think about it. If you're playing soccer, you kick a ball this way, someone else might kick it that way. That kick is unbalanced force acting on that ball because it's changing direction. Now, some examples of balance. Think of books on a table, okay? They're at rest. They want to stay at rest, okay? They don't want to move. Okay, it's something that's acting on it, pushing down by gravity, pushing up by, let's say they're on a table, so by the table. The table is pushing up. That is the reason why these cancel out. It has a net force of 0. So it's staying there and doesn't move. Now, for unbalanced, think of pushing a lawnmower. Okay, you're pushing, you're giving a force to the lawnmower. Okay, you're pushing it maybe this way, maybe the grass, the friction. It's a little bit that way, but bigger arrow means it's going to keep on moving. All right. Now, this word inertia. I know this is really tough word for a lot of us, but all it means is think of being stubborn, okay, or not wanting to change, okay? A lot of you are stubborn, so maybe that gives you a better understanding. For example, something resting will stay resting, okay? It's not going to want to move. Or a car stopping and you move forward, okay? You were moving when the car was driving, the car stops, but you still keep moving forward. The bus starts driving and you push back, okay? So if you've ever been on a bus, when it starts driving, you get pushed back because you weren't moving, and your inertia causes you to still not want to move. Also, you being stubborn and not wanting to do work. Okay, so think of that as inertia. All right. One last thing, you might have objects that are going down or up. If it goes down, it's negative. If it goes up, it's positive. All right, now you will have situations where you have word problems. All you got to pay attention to is the information they give you. So this is the last question I'm going to do with us. So a boy pulls a wagon with a force of 6 newtons east. Okay, so I'm going to write that down, or I'm going to underline 6 newtons east. Another boy pushes it with a force of 4 newtons east. What is the net force? All right, so we have 6n east and we have 4n east. So if they're both going in the same direction, we add them. 6 plus 4 equals 10. So this is 10 newtons east. Now we know a compass. We have north, south, east, and west. Okay? East is positive, north is positive, south is negative, west is negative. Okay? This is just a fancier version of me saying this. But I hope this clears up a little bit of confusion. I will have some of these questions in today's Nearpod, so make sure that you're working to complete the rest.